Okay, so it's time to start knowing a bit about artificial intelligence techniques and to have a general idea about what different methods we have in order to somehow try to make computers to be good at things they are not good at, okay? So we are going to try to describe the most important strategies we have when we develop artificial intelligence, and we are going to try to do that without too much detail, okay? So just a general introduction, but in order to give you an idea of what kind of things and technologies, okay, we have available in order to make artificial intelligence or AI. So a general classification of artificial intelligence, well, basically is a way to divide artificial intelligence is to divide it into two main groups, okay? What we call the symbolic artificial intelligence and the non-symbolic artificial intelligence, okay? So as you can read here, the first approach with more promising results, okay, at the beginning at least, was what we call symbolic AI. Starting from a top-down approach, it tries to describe a problem and its parts deterministically with symbols, rules, and representations. So the idea is that from knowledge from experts expressed by facts and symbols, their relations, rules, and the logic, these systems follows a deductive approach. Okay, so somehow what we try to do is to get all the knowledge of an expert, okay, and try somehow to convert this knowledge into rules and using some kind of logic, okay, to be able to, in front of a specific problem and using the rules, the logic, okay, using inference logic rules, we are going to have some kind of conclusions, okay? So we say that the system is going to follow a deductive approach. That is, from facts and statements, using some kind of rules and logic, the system can deduce new information and insights, okay? It is also common to have what we call high search spaces to find the solution. So this is when the problem to solve needs combinatory, okay? That implies the use of heuristics as a kind of criteria to reduce the searching space. So here you can see in this image, we have the tic-tac-toe game, okay? This is a traditional problem we have been able to solve using what we call symbolic AI. As you can see, what we do basically is to make the computer to explore all the combinations. So the computer is able to know exactly what is the right movement to do, because basically the computer, the algorithm, has explored all the search space. Well, in tic-tac-toe this is possible, but what happens with chess? What happens with the, for example, Asian game Go? The problem is that the number of combinations, if you calculate them, is higher than the number of atoms in the universe. So there's no way to solve the problem with this technique, okay? So what we have to do is basically the same thing, okay? To try to search and make combinations. But of course, in this diagram, what we try to do is, in these cases, to discard some options, okay? So this means that in every node of this tree, we apply what we call an heuristic, which means that somehow we try to figure out if it is interesting or not, okay, to explore, okay, this node, okay. So that's really difficult, and there's a lot of research in what kind of heuristics, of course, we can use in order to do that. But basically, this was the strategy that was used in order to beat Kasparov. You see the blue, okay? So, well, this is a traditional approach in symbolic artificial AI. So, symbolic AI is used in many reasoning and planning systems, and in healthcare has been used, and social as well. For example, in medical diagnosis or resources, planning resources and management. This means that the knowledge and rules of doctors and experts have been introduced into the system. This knowledge is expressed as rules, tables, decision trees, search algorithms, symbols, and so on. So the system in front of a collection of symptoms, for example, of a patient, and using a logic engine, can deduce the patient's state. The main advantage is that this system can totally explain why a decision is made. So when the system, the AI system, deduce something, we can know exactly what is the trace of the deduction process, okay? However, the main disadvantage are the difficulty in getting all the experts' knowledge and translate it into rules. So this means that we have a lot of difficulties in order to get the experience and the knowledge of someone from the social or healthcare sector, and to put it into a collection of rules and to have a logic engine in order to work with that. So another disadvantage is that generally these systems are less accuracy, okay, than other AI approaches, such as machine learning, which is the one we are going to talk about right now. So the non-symbolic AI is reaching popularity, and especially the models that belongs to what we call machine learning, okay? And much more in particular deep learning, a special machine learning technique that is on everyone's lips today, and the reason AI is almost every day in the news. So basically, we are talking about artificial intelligence because machine learning and deep learning right now. What we try with machine learning? Well, in this case, it's a bottom-up approach in which what we do is, from a collection of examples and historic data, estimate a relationship of function, we call it model, able to make predictions in front of new cases. So instead of using deduction, we use induction, okay? So as you can see here in this diagram, traditional programming or the traditional approach is that we get to the system rules, the program, okay, where we explain every action the computer has to do, and then we introduce the data, okay, we introduce the information for a specific problem. With that rules, the program, of course, and using traditional programming, we can get an answer to the user. In machine learning, as you can see, the things are totally different. What we do is to provide to the system answers and data. So for example, imagine that this is the example we are going to be talking about here. If you want to detect if someone has COVID or not, depending on the symptoms. So what we are going to do is to provide a large collection of examples with symptoms and if the patient has COVID or not. So the idea is that with a large collection of examples to be able to get these rules, okay? So somehow to estimate how in front of new cases, if this patient is going to have COVID or not, okay? So the idea is to get a model from a collection of examples in order to make predictions. This is what we call machine learning, And as you can see, we use what we call in logic the induction. So in machine learning, we work with cases where there is no known relation between input values and our result, or this function is really hard to estimate analytically. So we have to use previous examples, okay? So if it is very clear that in front of a collection of symptoms, what is the result? If this relationship is clear, we don't need machine learning. We need machine learning when, well, it is really very hard to know what makes someone to have COVID or not from a collection of symptoms. If we have a large collection of examples, then we can use these machine learning techniques in order to estimate a model able to deal with this problem. So in diagnosis, for example, imagine that we are able to get a lot of data of patients with symptoms and if they finally had or not COVID. So in machine learning, using many different techniques, believe me, there are many options, we try to estimate a function, relationship, a model between the symptoms and COVID or not COVID, okay? So the objective is to predict with the maximum degree of accuracy if a new patient, based on his or her symptoms, has COVID or not. So the only thing we have to do here is basically to have a large collection of information of previous cases where we have a lot of, in this case, patients with a lot of, with their symptoms, okay? And we know if they have COVID or not. So the machine learning technique, what it's going to try to do is to see how these features, these symptoms, okay, are related or they are related with the fact that we have COVID or not, okay? So finally we are going to get a model that we will be able to use in the future, okay, in front of new cases. And believe me, we do the things in the right way. This artificial intelligence system based on machine learning is going to be able to provide results of a high accuracy, helping, of course, us in order to know what to do in front of a patient with these symptoms. Problems in machine learning with unstructured information. In the examples we have, okay, in the previous example, for example, we know the features we need in order to make predictions. So we can know, okay, temperature, oxygen in blood, this kind of things. If we know these features, we can use some very well-known machine learning techniques. But we can have problems if this is not the case. So we have a lot of techniques that where we can put this information into a table or a similar structure. So we can use a large collection of machine learning techniques with these kind of problems. Our previous example, where we use real examples of patients with their symptoms and if they have COVID or not, it is a clear example where we can use many machine learning techniques with what we call structured data. However, many times this is not the case, and we are not able to provide what are the collection of features in a structured way. A clear example is for medical imaging, such as X-ray images. So here you have an example, okay? So imagine that in this case, we have a large collection of images, okay? And this case is an X-ray image from the lungs. And we know if the patient has COVID or not. This is our input now. How can we get this rule? How can we get this model? How can we, in front of a new image, X-ray image, to know if the patient has COVID or not? Here is where we are going to use another kind of machine learning techniques where we can work with non-structured information. So an X-ray image is, as any other image, a matrix of pixels of points of a specific color or grayscale. If we have many X-ray images of lungs, in this case, of patients with COVID and not COVID, well, what collection of features can I get from the image? In these cases where we use non-structured data, such as images, sounds, videos, medical signals, we need a technique able to not only learn the relationship between features and the disease, but what features to pay attention to as well. Okay, so the model has to decide automatically what to pay attention to, what are the main features, without the human intervention. Okay, this is the idea. This is when what we call connectionist AI can help us by using what we call artificial neural networks into what we call deep learning. So deep learning is a kind of subset of machine learning techniques that gives us also incredible results in front of non-structured information. So with deep learning, artificial networks, the system will be able to find a good estimation of the relationship or function between an X-ray image and to have or not COVID. And also automatically by deducing what features to pay attention to without human interaction. So we are just in charge of providing to the system a large collection of images, and if these images are from someone with COVID or not. So this deep learning model based on artificial neural networks is not only going to learn in front of a new image if we have COVID or not, but automatically has decided what features to pay attention to in the image without human intervention. The challenge, however, is in this case to have a large quantity of input images, what we call a data set, from a large diversity of sources and characteristics in order to be able to generalize in front of a new X-ray image and have good accuracy metrics and to avoid other problems, for example, bias. Not having X-ray images from many different devices, different people, ethnics, sex, age, in a balanced way is what, in almost any machine learning technique, the main cause of having what we call a biased model. Okay, so being less accurate, for example, with women. So in the charts you have here, if, for example, we are training our model with many more images of men and less of women, we can have problems, okay? Because we are going to have bias. So somehow we are not going to have as good results with women than with men. Or, for example, this is another possibility, if the images we are providing to the system are X-ray images, and most of them are non-COVID, okay, patients, and we have just a few collection of images with COVID, again, the model is going to have problems in order to get us good metrics when predicting in front of new images. So we have to be careful about that, okay, to be sure that we are using balanced information in order to avoid some risks, okay, using these artificial intelligence systems. So deep learning is based in what we call an artificial neuron, and an artificial neuron is somehow inspired in our neurons. Somehow, because they receive an input from a collection of other neurons, they make a simple processing calculation with this information and they give us a value that will be used by other neurons in a network. But artificial neurons are totally different to biological neurons in how they process the information and how we are able to train them. Okay, so the similarities is just that they receive inputs from other neurons, do a very simple calculation, and returns a value that it is going to be used by other neurons. This is the only analogy we can do with the biological neural networks. As a matter of fact, don't think that computers and devices really have inside artificial neurons. We simulate, of course, their functionality using complex calculations programs with the CPU or the graphics processing unit or other device hardware available. Okay, so basically what we use is what you have in the bottom, okay, in this chart, where a neuron is just receiving some inputs that can be the pixels of the X-ray image. These pixels, these numerical values can be multiplied. They are going to be multiplied by weights, by some numbers. They are going to be summed, and then a very simple mathematical function is going to be applied, and this is going to be the result this neuron is going to give, okay? So artificial neurons are generally grouped in layers in what we call artificial neural networks. Artificial neural networks must be trained with a large collection of input samples. The samples are given to the artificial neural network as a result, and the result, a prediction, is obtained. What happens? That at the beginning, of course, there will be an important difference between what the artificial neural network estimates and the real result. So what we do is, by using a complex iterative process, believe me, to take into account the error the neural network is doing in providing the result at the beginning, and taking into account this error, we are going to modify these weights for every single neuron in our artificial neural network. So these weights that somehow are considering how important this input is for a specific neuron is going to change accordingly to the error we have when we are training the neural network. So we are going to be training the neural network with real X-ray images, for example, and we are going to see if the neural network says COVID or not COVID. Depending on that, this error, if it is successful or not, we are going to change, using a complex process, the weights of all the neurons in order to improve the accuracy in front of new samples. And we are going to use all the available data in order to train the neural network. So finally, we will be able to have very incredible and good results, if we do it well, in front of new X-ray images, where we are going to have a very good prediction from the neural network. So again, if the amount of X-ray images with the right COVID or not COVID label is large and good enough, eventually the artificial neural network will give us good accuracies in front of estimating what happens in front of a new image. So here you can see a little simulation, okay, of the process, okay, but in this case trying to identify handwritten digits, okay? So what you have is an already trained neural network. This neural network has been trained with thousands of digits, handwritten real digits, and with the real label, telling if it is a 7, a 1. So after this training process, as you can see, the neural network is able to predict in front of a new handwritten digit what is the digit, what the digit is. So after a large training process in which we give to the artificial neural network many examples with the category or value that corresponds to them, for example, X-ray images and COVID and not COVID, the neurons of the artificial neural network will have a collection of good, well-trained weights, okay? This means that each neuron somehow will give more or less weight or importance to a specific input when generating its output. Here you can see what happens when we have a well-trained artificial neural network in classifying handwritten digits, and exactly the same technique can be used in order to use it in any medical imaging, okay? Like X-ray images. So in short, and in order to finish, there are two main approaches to artificial intelligence, the symbolic and non-symbolic. Symbolic AI is good for interpretability, but difficult as we have to introduce the rules from experts, and less accurate than machine learning. An important part of what we call machine learning techniques are not symbolic. With machine learning, we provide a lot of real examples, and a model is obtained for making predictions in front of new examples. Deep learning, which is a specific type of machine learning technique, using artificial neural networks, allows to work with unstructured data, and it is also able to train and get a prediction model with no need to specify features. So just what we call raw information, such as images, video, sound, medical signals, etc. However, artificial neural networks are almost black boxes, so once they are trained, it could be almost impossible to know why it makes a specific decision. So that's a very problem, okay? It's not easy to know why a neural network has made a specific decision, something that can be a problem in some context, for example, in the health and social care sectors. Okay, so with this large video, we have enjoyed a kind of introduction to the main techniques of artificial intelligence, specifically machine learning and deep learning. So in the next video, what we are going to see is just some examples of the many examples we have of artificial intelligence systems in the social and healthcare sectors.